we're going to be looking at a specific type of factoring, which is looking at factoring of difference of squares. So we can recall when we multiplied x plus 6 times x minus 6. We can think of foiling this to x squared plus 6x minus 6x minus 36. And those two middle terms ended up adding to 0, leaving us with x squared minus 36. This is what we are going to call a difference of squares. Note that x squared is a square, 36 is a square, and difference means subtraction. Now, did we ever multiply to get x squared plus 49? Well, let's take a peek. We could look at x plus 7 times x plus 7. And distributing and foiling, we have x squared plus 7x plus 7x plus 49. So those middle two terms add up to 14x. Sometimes students will say, well, x plus 7 quantity squared. But this is also not a sum of squares because this would equal what we just multiplied, those two binomials of x plus 7 times x plus 7. So, did we have a sum of squares? No. There is no sum of squares that can be then factored. So, we need to recognize these difference of squares. Factoring a difference of squares, once you're able to recognize it, is really looking at our first term, in this instance x squared, and saying what two numbers that are the same multiply to give us x squared, x and x. Then we can look at the idea of our last term, 9, which is also a perfect square. 3 times 3 multiplies to 9. And we know that we want that middle term of 0x that we talked about to go away. And so we have an addition sign and a subtraction sign. And it doesn't matter whether you write this as x plus 3, x minus 3, or as x minus 3, x plus 3. Either way, when you FOIL or multiply this back out, you see that we have that x squared plus 3x minus 3x minus 9. We definitely get that negative 9 by multiplying by a positive and negative, and these middle two terms become 0x. So, difference of squares is often a binomial where you take the square root of the first term, x squared. The square root then would be x and x. We have an addition and a subtraction sign, and then the square root of the last term, 3 and 3. So let's look at some differences that could come up. 4x squared minus 49. Well, this is a difference of squares. 4x squared is a square, 49 is a square, and we do have a subtraction sign. So we look at this as 4x squared. Well, looking at it as the square root, we can say that 2x and 2x multiply to 4x squared. 7 multiplies to 49, 7 times 7, and we have an addition and a subtraction sign because this will ensure that our middle term will become 0x. 18 minus 2a squared. Well, we have a hint to remember always factor out the greatest common factor, and the greatest common factor in this instance is 2. Factoring that out, I have 9 minus a squared. Now, don't get 9 minus a squared confused with a squared minus 9. They're similar but slightly different. So, let's continue with how we know to factor a difference of squares, which is to look at what two numbers, same numbers, multiply to 9. That's 3 and 3. And those are going to go in our first slot in the binomial because 9 is in the first position. And we know we're going to have a plus and a minus, and a squared will be an a times an a. So 2 times 3 plus a times 3 minus a is the solution to the factored form of 18 minus 2a squared. P to the fourth minus 16. Well, this is a little bit of a challenge, but let's take a look. P to the fourth is a square. The square root of that is p squared. And 16 is also a square. It's 4. And what's interesting about this is something that we can break down again. It's a double breakdown because p squared minus 4 is another difference of squares. P squared is a square, 4 is a square, and we are looking at the difference. So we still have our factor of p squared plus 4. Remember, we do not have a sum of squares that factors. And p squared minus 4 would become p minus 2 times p plus 2 in its factored form.